You'll often want to apply a command line command to more than one file, maybe to lots of files. To save you from typing each name individually, there is a small set of wildcard characters that can be used. These are sometimes called globs, and the process of using them is called globbing. Before we get started with globbing, though, I want to highlight something that can get a little confusing. Globs are one of two classes of wildcard characters you'll encounter at command line. The other is regular expressions. Globbing and regular expressions both provide wildcard characters for matching patterns of text, but they're applied in different scenarios. Globs are for matching patterns in file and directory names, while regular expressions match patterns of text inside files. In addition, and this is what causes the most confusion, the meaning of a given wildcard character is sometimes different between the two. We'll cover regular expressions in other videos and focus here on globbing. If you want to follow along, you'll need the example files, which you can get from Google Drive at the location on the screen. I've also added that link as the first comment on this video. Once unzipped, there will be 36 files that you can drop into your working directory. These represent data from a hypothetical study in which 3 experimental treatments, denoted treat 1, treat 2, and treat 3, were applied to samples, the effects measured at days 2, 7, and 12, and the entire experiment performed twice. The 2 replicates are indicated with the A and B designations in the file names. For each combination of treatment, time, and replicate, there are 2 data files, raw values and log transformed values. One piece of good news as we start globbing, the set of wildcard characters is small, so they're pretty easy to learn. They include the asterisk or star, the question mark, square brackets, and the caret. In globbing, the star is the most flexible wildcard. It matches any character any number of times. Basically, it matches anything. The question mark also matches any character, but one and only one character. Square brackets allow you to match any character from a specified set. Having A, B, C inside square brackets would match either A, or B, or C. Matching is case sensitive, and ranges can be defined inside the square brackets with a dash. For example, putting capital A dash capital Z, lowercase a dash lowercase z, 0-9 inside square brackets would match any letter, regardless of case, and any number. If you want to match the dash itself, it needs to be the first character inside the brackets. Otherwise, it's interpreted as defining a range. Finally, the caret can be used inside the square brackets to negate a match. For example, caret ABC inside square brackets would match any character except the lowercase a, b, or c. Within my terminal, I'm going to list the files in my current directory just as a reminder of what we're working with. As a first example of globbing, let's move the raw data files, those ending in raw.csv, to their own folder. I'll use the mkdir command to create a new directory named raw data, and then the mv command to move all of the files ending in raw.csv to that folder. Here, the star is matching all the characters up to raw.csv in each of those file names. Note the / at the end of the raw data folder name. This was added when I used tab completion to automatically fill in the name of that folder. The command will work the same way with or without this /. We can use ls to check things worked as expected. Note the new raw data directory. With the raw data files out of the way, let's try listing all of the 2-day files from what's left. We'll use the list command, ls, but limit the results to the files that match the pattern star 2d star. Notice I didn't get exactly what I intended. I did get the 2-day files, but I also got the 12-day files. This highlights the importance of thinking through all the ways your glob is going to match to try to avoid getting unintended matches. Okay, next, let's say we wanted to focus an analysis on the files associated with treatment 1 or treatment 2 from days 2 or 7. We'll separate those files into a folder called First Analysis, which I've created here. We can move those specific files into that folder with mv space treat square bracket 1 2 square bracket question mark underscore square bracket 27 square bracket star space first analysis. Here, we've matched 1 or 2, but not 3, immediately after treat. Then, the question mark allows for any single character after the 1 or 2, in this case, either A or B. Square brackets are again used to match either 2 or 7 as the time point, and the star matches the D for day and all the remaining characters. Of course, the first analysis part tells the move command where to move the matched files to. Again, we can check things worked with ls. We've moved all of the 2 and 7-hour data files for treatments 1 and 2. Finally, let's say we find out there were some problems with the treatment 3 part of the experiment and we just want to delete those files. We can remove the log transform treat3 files in the current directory with rm space treat3 star, and then we can delete the original treat3 files that we previously moved to the raw data folder with rm space raw data slash treat3 star. This leaves us with a working directory that looks like this: 2 folders, first analysis and raw data, and 4 files. Make sure to exercise some caution when using globs, especially with a command like remove, as like we saw earlier, it can be fairly easy to match something you don't intend, especially with a general wildcard character like the star. While there are often many ways to structure your expression, it's good practice to make it as specific as possible to help avoid those unintended matches. Nevertheless, just knowing these few basic glob characters is going to come in handy nearly every time you work at command line. And don't forget, globs and regular expressions are 2 different things. Globs apply wildcard characters to file names and directory names, while regular expressions apply them to text inside files. And importantly, certain wildcard characters mean different things between the 2. You can check out the videos on regular expressions for more information on those.